Jai Jagannath. Welcome to Mo Physics. So, today is the last class of chapter 21, that is lecture number 6. So, here I will solve some exercise problems from University Physics book. So, let us start with exercise 21.19. Now, see. So, in the question, it is given Q1 is equal to 3 microcoulomb. It is placed at the origin, and Q2 of minus 5 microcoulomb is placed at 0.20, and all are in meter. So now you see, these two charges are lying on which axis? X axis. Now question is, where Q3 of minus 8 microcoulomb is to be placed on x axis, so that net force on Q1, that is 3 microcoulomb, will be 7 Newton in negative s direction. Okay. Now see, according to the question, it is given the force on Q1, which is equal to 3 microcoulomb, is how much? Is 7 Newton. In which direction? In negative s direction. Okay. So for this condition, where I have to put Q3, whose magnitude is minus 8 microcoulomb, on the x axis. You see, this is the origin. Okay, you see, this Q2 is a negative charge. So this negative charge will exert a force on this positive charge, that is 3 microcoulomb. In which direction? Towards right. This negative will attract this positive. So this force is, say, it is force by which charge? 2, Q2, on which charge? 1. So this force is towards positive charge. But I have to find, we have to consider the net force on Q1 is towards negative, and this is positive charge. So definitely I will put, and you see what is the nature of Q3? It is a negative charge. So if I will put this negative charge here, suppose I will put Q3, whose value is how much? Minus 8 microcoulomb in negative x-axis. So let us say the coordinate of this Q3 is minus x 0, because it is lying on the y-axis. Y coordinate is 0. And from this origin to this Q3, the distance is x. So now you see, this is minus charge. So this negative charge will attract this positive charge towards itself. And this force is equal to what? Force by Q3 on which charge? Q1 charge. So here on Q1 there are two forces. One is F31, another is F21. But what is the net force? Net force is towards left side. So definitely for this condition, F31 must be greater than F21, so that net force will be, net force on Q1 charge is equal to, it will lie in left direction. That is, net force is equal to F31 minus F21. But according to the question, what is the net force magnitude? That is 7 Newton. And what is F31? What is the force between Q3 and Q1? So we know K, Q1 Q2 by R square, that is 1 upon 4 pi epsilon naught. So you directly write down what is the value of 1 by 4 pi epsilon naught? It is 9 into 10 to the power 9. So 9 into 10 to the power 9 K, Q1 into Q3. So that is 3 microcoulomb, 3 into 10 to the power minus 6, into, what is the magnitude of this charge? 8 microcoulomb, Q1 Q2 by R square. So what is the distance between Q1 and Q3? That is unknown, that is say x. Minus, what is the force between Q2 and Q1? Q2 and Q1. So what is the magnitude? Same 9 into 10 to the power 9 into Q1 is 3 microcoulomb, 3 into 10 to the power minus 6, into, what is the value of Q2? 5 microcoulomb, 5 into 10 to the power minus 6, divided by, what is the distance between Q1 and Q2? 0.2, that is in meter, 0.2 square. So now you solve this. You can solve this. So I am not giving detail. So everything is known. X is unknown quantity. So solve this x. You will get x is equal to 0.144 meter. X is equal to 0.144 meter. Then where will be the position of this Q3? Where we have to put this Q3 value? So the position or coordinate of Q3 should be at which point? At minus x0, that is minus 0.1440 meter. So this is the solution. Now see, next is example 21.7. You see, there are two plates separated by 1 centimeter distance apart. The upper plate is connected to the negative terminal of the battery and positive plate is connected to the positive terminal of the battery whose EMF is 100 volt. Okay, this is the 100 volt battery. Now an electron is released from rest from top plate. The release from rest means initial velocity of the electron is 0. So initial velocity is equal to 0. That is, initial velocity along y direction is equal to 0. And this electron is released from the top. So we have to find what is the acceleration. Now see, this is positive plate, this is negative plate. In between these two plates, there will be an electric field. And in the potential chapter, next chapter, we will know that electric field intensity inside these two plates or in between two plates is negative potential gradient. That is E is equal to minus dV by dr. Okay. So if the electric distance is the same, the voltage is the same, and the plate area, the length of the plate is very large, then we can say there is an electric field will be developed inside the plate, and that electric field is assumed to be uniform. And you know, electric field direction is always from positive to negative direction. This is the direction of the electric field inside the plate, positive to negative. And what is the value of electric field? It is nothing but the potential difference. What is the potential difference here? 100 volt. Okay, so this negative terminal is connected to here, positive terminal is connected to here. If the potential difference between these two terminals of the battery is 100 volt, potential difference between two plates is also 100 volt. Divided by distance. Distance is what? 1 centimeter. 1 centimeter is nothing but 0.01 meter. So from this we can say the electric field intensity inside the plate is equal to 10000 volt per meter. So this is the electric field intensity. Clear? So now again we know the concept. When any charged particle, suppose this is the negative plate, this is the positive plate. So an electron is released. Electron is which charge? Negative charge. And what is the direction of the electric field? From positive to negative. So this electron, which is a charged particle, will experience a force opposite to that of electric field. Electric field is upward, so force exerted by the electron or force experienced by the electron will be in downward direction. So what is the value of force? Force is equal to Q into E. So here force experienced by the electron is equal to Q into E. So what is Q? Q is the charge of electron into electric field. So what is the value of E? 1.6 10 to the power minus 19 into electric field intensity, which you have got 10 to the power 4. So you can calculate it is 1.6 into 10 to the power minus 15 Newton. So this is the force experienced by this charged particle. Then question is, what is the acceleration? Since force is in downward direction, so acceleration will be also in downward direction. What is the value of acceleration? Force by mass. So force is equal to 1.6 into 10 to the power minus 15 divided by mass. So what is the mass? Mass of the electron is 9.11 into 10 to the power minus 31 kg. So if we'll calculate, I think it will come 1.76 10 to the power 15 meter per second square. And what is the direction of the acceleration? Direction of the acceleration is downward. Next, second bit. So this is the answer of first bit. Second bit. What is second bit? Speed and kinetic energy after reaching lower plate. After reaching the lower plate, what will be the kinetic energy and what will be the speed of the particle? So here, what is the speed of the electron you have to calculate, and what is the kinetic energy at the bottom we have to calculate. So now we have already read about the work energy theorem. So what is work energy theorem? So work done by the electric field to bring the electron from upper plate to lower plate is equal to change in kinetic energy. We know work done is equal to change in kinetic energy. According to which theorem? As per work energy theorem. So now again, you know, in school also, in 10th class, I think, in electricity chapter, you know, the potential difference V is equal to amount of work done by bringing a unit positive test charge from infinity to that point, or the potential difference is equal to work done by bringing a unit positive charge in between two plates. So, or you can say W is equal to V into Q0. So here, work done by bringing this charge particle, that is electron, from lower plate to higher plate is equal to potential difference. Potential difference is what? V. And what is the value of a charge? Charge of electron is called E. So W is equal to EV. That is called electron volt. So here work done is equal to 1 electron into 1 volt. Okay. So, but here W is equal to EV. So here V is equal to what? So I can write W, which is equal to charge of electron, that is E, that is 1.6 into 10 to the power minus 19 coulomb, into V. What is V? V is the potential difference between these two plates. So what is the potential difference between two plates? 100 volt. Just multiply 100 volt. So this is the work done. And this work done is equal to change in kinetic energy. So what is change in kinetic energy? It is final kinetic energy minus initial kinetic energy. Change is always final minus initial. So what is the final kinetic energy? Let us say KEF. And what is the initial kinetic energy? Half mv square. So here half mass of the electron into initial velocity of the electron is how much? 0. So that implied the final kinetic energy is equal to this value. So which is equal to 1.6 into 10 to the power minus 17. What is the unit of kinetic energy? Joule. So this is the answer of kinetic energy at which the electron will strike to the ground. And question is, what is the final velocity of the electron? So since you know kinetic energy is equal to half mv square, so that implied v square is equal to 2 times kinetic energy by mass, or v is equal to square root of this. So here you have got kinetic energy. What is that value? 1.6 10 to the power minus 17 divided by mass of electron. Mass of electron is nothing but 9.11 10 to the power minus 31. Just take the square root. So if you will calculate, just calculate using calculator, you will get 5.9 into 10 to the power 6 meter per second. So this is the speed of the electron at what it will strike into the ground. Third bit is the question is how long time it takes to travel. That means electron is released from lower plate to upper plate to bottom plate. During this journey, what is the distance covered? 1 centimeter. So at what time it will strike the lower plate? So you know V is equal to U, V velocity along y direction is equal to Ui plus Ayt. So here the velocity at what it will strike the ground is equal to, we have calculated 5.9 10 to the power 6. And what is the initial velocity of the electron? It is released from rest, that is 0. Plus what is the acceleration? We have already calculated 1.76 10 to the power 15 into time. So you can calculate from this time. So if you calculate the time, you will get 3.4 into 10 to the power minus 9 seconds. So this is the traveling time of electron from upper plate to lower plate. So you see, test your understanding 21.7 of the book. So here question is given, dipole moment and electric field are opposite. If opposite, then dipole is unstable or stable, or neither stable nor unstable. So we have to state what is the answer. Now see, suppose the electric field is given towards left direction, and here it is a dipole minus q plus q, and you know what is the direction of the dipole moment? It is always from negative to positive. So this is the direction of the dipole moment, this is the direction of the electric field. So here this is the direction of dipole moment, this is the direction of the electric field. Then what is the angle between P and E? That is theta, which is equal to 180 degree. Now question is whether it is stable or unstable. So easy solution method is that you know what is the formula of potential energy. We have already discussed in the theory. Potential energy of a dipole. Potential energy of a dipole is equal to minus. How will you remember the formula? Potential starts from the word P. Energy starts from the word E. But potential energy is a scalar quantity. So dipole moment is a vector quantity. Electric field is a vector quantity. Just take a dot product. So this is the potential energy of a dipole, minus P dot E. So here that is minus P into E into cos theta. Theta is what? Theta is 180 degree. So cos 180 degree is equal to minus 1. So that is equal to potential energy, here minus 1, that is plus P. So here this potential energy is maximum. And we know potential, if a body or if a system has maximum potential energy, then it is unstable. It is unstable. Just imagine a bigger tree, a large tree, and a small tree, small height tree. So which is stable, which is unstable? You see, the bigger tree has center of mass here. The height is more than that of smaller tree. So in the smaller tree, the height, the center of mass is lying at a small h height from the ground. It is small height here. Here the height of this tree is more. So that means potential energy is equal to mgh. Since h is higher, here h is lower. So here potential energy is more, here potential energy is less. So during any storm or cyclone, so this bigger tree is affected. Why? Because its potential energy is more. Potential energy is more means it is unstable. Potential energy is less means stable. So this is the one reason. Another. Suppose you know, if I will rotate, or if the dipole is displaced by small angle, towards which side? Towards clockwise direction. Suppose this dipole is displaced by some angle theta, in which direction? Anti-clockwise direction. So what will happen? A torque will be developed. So here minus q will come in downward and plus q will come here, and you know this positive charge will experience a force due to electric field along which direction? Along the direction of the electric field. So this is a force, and this negative charge will experience a force opposite to that of electric field because it is negative charge. So here you see this force and this force will produce a couple, and that couple will produce a torque, and that torque will rotate this dipole along which direction? You see the direction. So this is the force. This is the force. So it will create a moment in which direction? Again in anti-clockwise direction. So you have already displaced through small angle in anti-clockwise direction. After that, the torque developed in the dipole will also produce a torque in which direction? Anticlockwise direction. That means after small disturbance, the dipole will not come back to its original position. That's why it is unstable. So answer is unstable. Now this is question number 11. This is exercise 21.1. This is exercise 21.1. Question is given. The mass of lead sphere is 8 gram. So what is the mass of lead sphere? It is given 8 gram. And a net charge on it is this much. The net charge on this 8 gram of lead is equal to minus 3.2 10 to the power minus 9 coulomb. You have to find the excess number of electrons. So definitely, since the charge of lead sphere is negative, that means there is surplus of electron. And what is the excess number of electrons present in this 8 gram of lead, 8 gram of lead? You know, so you know Q is equal to always plus or minus Ne. So if I will tell Q mod magnitude of the charge is equal to Ne, so that implied N is equal to magnitude of charge by E. So what is the magnitude of charge? 3.2 into 10 to the power minus 9. What is the value of E? It is the basic unit of charge, which is equal to. So just you calculate this. I think if you divide, you will get 2 into 10 to the power 10. So this is the excess number of electrons present in 8 gram of the lead sphere. So now second question, how many excess electrons are there per lead atom? So whose atomic number is 82 gram? Atomic number is 82 and its atomic mass is 207 gram per mole. So first we will calculate in 207 gram of lead atom, how many atoms are present. So from the chemistry, you know the in, so be it in 207 gram, the number of atoms present is equal to Avogadro's number. So what is Avogadro's number? 6.023 into 10 to the power 23. So in 207 gram, number of atoms present is this much. So in 8 gram of lead atom, the number of atoms is equal to 6.023 into 10 to the power 23 divided by 207 into 8. So if you calculate, it will come 0.2327 into 10 to the power 23. 10 to the power 23. So now you see, so in 8 gram of lead atom, number of atoms present is equal to this. We have already discussed in 8 gram of atoms, in 8 gram of lead, how many excess electrons are there? 2 into 10 to the power 10. That means in 8 gram is equivalent to what? This number of atoms. So in 0.2327 into 10 to the power 23 atoms, the number of excess electrons is equal to how much? 6. That is 2 into 10 to the power 10. So in one atom, the number of excess electron will be how much? 2 into 10 to the power 10 divided by this much, 0.2327 into 10 to the power 23. So if we'll calculate this, I think it is coming 8.59 into 10 to the power minus 13. So in one atom, the number of excess electron is this much. Okay, I think it is clear. So This is the last problem, that is exercise 21.70. Now you see, two charged sphere, that is identical sphere, mass same, that is m, and charge of both are same, that is q, and the two charge sphere are connected to a light string whose length is l. So this q charge will repel this q will also repel. So at the equilibrium position, you have to show that the distance between these two charges d is equal to this. Okay. So what we'll do, you see, if I'll draw the free body diagram, you see, this is the first charge body q, this is the second charge body q, the distance of separation is d, this is the middle point, and this angle is theta, and it is given theta is very small. Okay, so now you find what are the various force acting on this charge body. So what are the various force acting on the charge body? If we will immediately write the gravitational force acting on the body q is downward, which is equal to mg. This is the gravitational force. Now this q will repel this q along this direction. This is which force? Electrostatic force. What is the formula? K q1 q2 by r square. K is equal to 1 by 4 pi epsilon naught q1 into q2, that is q into q, which is equal to q square, divided by distance of separation is d, so d square. So this is the electrostatic force between these two bodies, and there is a tension developed in the string. This is tension T. So just draw a vertical line here. If this angle is theta, this angle is also theta, that is alternate angle. So now this T can be resolved into two components, one along vertical direction, another along horizontal direction. So what is the component of T along this vertical direction? It is just making theta angle with this axis. So the component of this T along this direction is T cos theta. And what is the component of T along this direction? It is T sin theta. So now since this charge is in equilibrium position, the net force is equal to 0. Net force is equal to 0. Net force means upward force is equal to downward force. Right direction force is equal to left direction force. So what is right direction force, or what is left direction force? T sin theta. What is the right direction force? Q square by 4 pi epsilon naught d square. Let us say this is equation number 1. Then upward force is equal to downward force for equilibrium position. What is upward force? T cos theta. What is downward force? mg. This is your equation number 2. So now equation 1 divided by equation 2. If we will divide T sin theta by T cos theta, T cancel. So it will be tan theta. Tan theta is equal to Q square by 4 pi epsilon naught d square divided by mg. So this is tan theta. But it is given theta is very small. If theta is very small, we know from mathematics, if theta is very small, sin theta is equal to theta, which is also equal to tan theta. So in place of tan theta, I will write sin theta. So sin theta is equal to q square by 4 pi epsilon naught d square mg. Okay. So what is the value of sin theta? You see, this is theta. So this is the right angle triangle. So in front of theta, this is perpendicular, this is hypotenuse. So perpendicular is nothing but half of d. This is total d. So this distance is equal to, so sin theta, in place of sin theta I will write d by 2 divided by hypotenuse. What is hypotenuse? Length of the string. Length of the string is L. So which is equal to q square by 4 pi epsilon naught d square mg. So that implied d square d, that is dq by 2L is equal to q square by 4 pi epsilon naught mg. Okay. So here 2, here 4, cancel, that is 2. So now what is dq? So dq is equal to dq is equal to q square L divided by 2 pi epsilon naught mg. This is dq, but we have to find d. So d is equal to just cube root of this, q square L by 2 pi epsilon naught mg 1 by 3. So this is the answer. So we proved that d value is equal to this much. So with this, I am concluding the chapter 21. So I think you enjoyed the chapter 21. So next we will start chapter number 22. So till that you enjoy all the videos. Okay, bye.